So on that note, Hans has started to share his screen. I'm going to hand over the controls in a second to Hans and enable him to make his presentation. I think Hans has spotted the various comments about his audio. I think if Hans doesn't have another microphone, we're just going to have to make our best with it. And I really apologise that I think Hans has done the best he can. So you're going to have to put on your best amateur radio ears to get Hans's contribution. So Hans, I'm going to hand over to you and allow you to run the your slideshow. Thank you, Hans.
Okay. Thank you, Nick. Yes, I actually do have no other microphone on this computer. I could dial in on an iPad, but then I wouldn't have access to the slides. So I'm not sure if it's possible to speak from one account and share the screen from another account. But I'll try and speak as close as I can to the microphone and look at it and not move and sit here like a statue. Does it sound any better? Nick, you're muted. I see you talking, but you're muted.
Yeah, Hans, we've just had a couple of comments from people saying it does sound a bit better. So 2 or 3 people have said sounding better. So just press ahead as you are.
Okay, all right. Yep, I thought if I try and go to another device or something and share from this one, it might confuse things. Right, so I have shared my screen and hopefully everybody can see that. And I want to talk on 5 different topics, and there's quite a few slides, but I think it will take about 50 minutes and we should have time for about half an hour of Q&A afterwards. First, I want to talk about my beginnings in radio and how we got to where I am today and what I'm doing today. And then I want to move on because I heard from some survey in the beginning of the planning for this event, that people would very much like to hear from me about the QCX and the new QCX Plus and also the QSX transceiver, which I have under development. So I want to talk about all of those things in turn, but start first about me and my beginnings. So this is me and my beginnings. This was a birthday present, I believe, for my 6th birthday, which would place it around the summer of 1977 in South Norwood in London, South London. And this is a crystal set, and you can see that at some point many years later I still found it and photographed it. Many of us may have started with this type of set. To me, it was an absolute revelation that having wire strung around on the living room floor, I could actually hear radio stations on this thing, and of course, particularly not having any battery. Was always fascinating. In 1982, so a little bit later, this was my first real receiver, which was a 4-transistor regenerative receiver built in a plywood cabinet with the Jackson Brothers reduction dial there on the front. I had a lot of help from my father, who was he didn't have an amateur radio license, but he was definitely a constructor of radios and a designer of radio. Then in 1988, I have this valved regenerative receiver, tubes if you're listening from America, 2 valves that you can see there, and again, regenerative, and again with some advice from my father because valves were his thing. Then we roll along a bit to when I finished my university, and I got licensed as G0UPL in 1994. I have to say that for most of my teenage years, I was more of a digital electronics experimenter, and I was very much into the first computers that came out, the ZX Spectrum, for example, and the ZX81, and I was teaching myself programming on those. And so I spent relatively less time on analog electronics, which was always very scary to me. This was my first real transceiver. So everything we've spoken about before now has just been receivers. This is my first transceiver, which was a kit from Tim Wolford, G0UPL, Wolford kits. He's still selling Wolford kits, and they still look very much in the same format. So good for him to have continued and kept up with it for so long. It's a tough business to be in. So this was a very simple direct conversion double sideband transceiver with an SA602, NE602, NE612, all equivalent, and an IRF510 for the power amplifier. I actually found this yesterday when I was preparing my slides, and took a photograph of it, so you can see it's collected some dust over the years. I never had a QSO on this one, and I was somewhat optimistic sitting in my apartment in London at that time, having finished university and looking for my first job. And I had an antenna of some wire wound up around a plastic drain pipe indoors, and I was expecting to hear something on 160 meters in the middle of a block of flats. And of course I didn't, and I listened and listened for days and weeks, and eventually I did manage to hear a QSO between an Italian station and a Greek station, and so that was considered a success, but I never used it actually on air. I then got busy with work and my first job and everything, and I sort of drifted away from radio for about 7 or 8 years, but kept up with Sprat and the Radcom publications, and particularly the Pat Hawker column in Radcom, the Tech Topics column. And it was basically inspired by that column that I came to my first real station in 2002 and had my first QSO in March 2002. And I used to call this station my love letter to Pat Hawker, because most of the modules in the receiver and the transmitter and the ATU, all of it had come out of Radcom, mostly from Pat Hawker's Tech Topics column. So some of the things I had in that station, I had this one valve transmitter with a triode femto valve, the ECL82, and a 3.560 megahertz crystal for 80 meters CW calling frequency. On that frequency, I met many of the members of the G-QRP club and made many good friends, and practiced my CW and had many long rag chews, up to 3 hours in some cases. And as well as that, they managed to contact many people around Europe on 80 meters in the evenings, particularly winter evenings. So that was a huge amount of fun. And that was just the transmitter side. The receiver side was this phasing method direct conversion receiver, and you can see I've had a lot of fun with that. I put in a nice wooden enclosure. I built a clock for it, which you can see on the top left, and a frequency counter that you can see on the top right. This contained a analog LC VFO with huff and puff stabilized tuning, and it contained a quadrature sampling detector type of direct conversion mixer down to audio with phasing method direct conversion to cancel the unwanted sideband. So this was my first real experiment with receivers and with the payload detector, quadrature sampling detector method of receiving. And so that was kind of where I began on that whole technique. A lot of fun with that radio. This is some details about the modules. This diagram appeared in an RSGB handbook at some point, showing the block diagram of the receiver. Virtually, as I said, all of these modules were derived from or developed from articles in Pat Hawker's Tech Topics column in Radcom. Pat wrote that column, I believe, for about 60 years, continuously non-stop, and really it was an amazing inspiration to me, and often the thing that I turned to first in Radcom. Sometimes the only thing, I have to admit. Then roll on to 2003, so not very much later, and I somehow got interested in the weak signal modes, which became kind of a fascination for quite some time thereafter. And weak signal modes are basically, the very simplest one is QRSS, which is just an on-off keyed CW, Morse code, but with very, very slow dips, so that you, instead of decoding it audibly in your ears, you run a spectrum analysis program such as Argo that you see pictured there on the right-hand side, and you look for small frequency shifts on that or on-off keying. And because of the very narrow bandwidth, because it's so slow, typically around 5 seconds or 10 seconds dip speed, you have a very, very high signal-to-noise ratio, and very low powers can be copied all over the world without much difficulty. There is still a very active group of experimenters playing with this mode, and it also, of course, went on to the much more popular Whisper mode, which is a similar concept with four encoded tones and 162 symbols, and it transmits the call sign, locator, and your power level. So back in 2003, I had this crazy controller which generated this. Now, the proper way to generate QRSS and Whisper and FSP-CW type of modes is to use a computer or a microprocessor. What I did, I had a memory chip and some logic chips that counted up and cycled through the memory locations, and some logic to shift an oscillator at the output, and a bunch of switches and buttons that allowed me to control and to program each of the memory locations. And so it was a very, very manual and tedious process, but a huge amount of fun. So that was around 2003, late 2004. I've left out a huge number of projects in the interim between all of these projects. These are just a sample of the things that I had played with. We don't have time, obviously, today to talk about them all. So the next one I want to talk about is this very small QRSS transmitter which fit in a mint tin. This is not an Altoids tin, it's the smaller type of mint tin. They're called ozone mints. And this had a 8-bit microcontroller to generate the encoding, and it just encoded UPL, the last 3 characters of my call sign, and applied a 5 Hz shift via a red LED which was being used as a varicap or varactor diode. So I actually built this about 2 hours before we were due to leave for Heathrow Airport to go on a 2-week vacation in Grenada in the Caribbean. And yeah, my wife is somebody who the closer it gets to the time you have to leave the holiday, the slower she gets. And so it wasn't until about 3 a.m. that she was finished with her packing. And by that time I thought it's hardly worth going to sleep, so I just decided to build this transmitter and take it with me. And as soon as we got there, I strung up a dipole antenna and I powered it from my mobile phone charger. And it was copied almost immediately in Alaska, various parts of America, in Europe, UK, and so with 100 milliwatts or so of power. And so that was a tremendous fun. That just ran 24 hours a day, and as you can see in the top right, I picked up a very cheeky little girl there on the beach who came and started copying my pose. My wife was trying to take a picture of me, and she just sprang out of nowhere and sarcastically copied my pose. We had a great time in Grenada, and this kit was a lot of fun to operate there in the background while we were enjoying the nice scenery. Well, the important point about this kit and why I mention it is because a year later I was invited to FDIM in May 2010 to present a seminar on QRSS and weak signal modes. And Steve G0UPL and I had the idea that we would create a kit for a QRSS transmitter. And this kit was basically a direct copy of this earlier tropical QRSS transmitter, which I had used about a year earlier in July 2009. And so I laid out a PCB for it. Not a very good PCB. I think that was my first attempt ever at creating a PCB. And so it's not a terribly good PCB, and single-sided and bad layout and everything. But it worked very well, and we made 100 of these kits, took them along to the FDIM seminar, and they all sold out within the same day on the vendor evening there. So I was selling them for $15, and it was the first kit of QRPLabs. And so, one moment. I still think my microphone is quite far down. I don't know if this helps at all. So I sold those for $15 at the vendor evening after the presentation, and there was literally a pile-up snaking around the room for 3 or 4 hours because I had to program each of those 8-pin microcontrollers individually after typing in the operator's call sign into the program, compiling it, and then downloading it into the microcontroller. So that was a lot of fun and very popular. People, of course, enjoyed the low price too. Then that over the years, over the following few years from 2010, which was the first QRPLabs kit, until 2016, the kit range gradually expanded, and I think it was 2012 that the ultimate transmitter kit came out. I see I slipped a slide there. Yes, 2012. So this used a larger microcontroller and provided standalone generation of quite a number of weak signal modes, including Whisper, very importantly, the weak signal propagation reporter, which is, I think, the most popular of the weak signal modes, and what about 90% of people or more use the kit for. So this used a very low cost LCD as well as everything was very low cost, and it cost, I think, in the end something like £15. It was slightly more expensive than the original QRSS kit, but still a very, very low price kit, and that was very popular. And that developed on over the next 3 years to the next in the series, the Ultimate 2, and then the Ultimate 3, followed by the Ultimate 3S. And so the Ultimate 3S is still a very big seller for the QRPLabs kit range, but it was joined also by a number of other modules, such as low-pass filters, band-pass filters, a relay-switched filter board, a Si5351A synthesizer, and I'll come on to that in a moment, an OCXO kit, a GPS receiver kit. There was a 5-watt PA kit associated with this as well, and the enclosure that you see there in the picture. And so for many years, this Ultimate 3S QRSS and weak signal transmitter was the only kit you could buy for Whisper. It isn't now, there are other people producing them too, but for many years it was the first and the only QRSS as well as Whisper transmitter kit, and was the main product of the QRPLabs product range. So then in 2016, I left my career in IT, in banking, in order to pursue QRPLabs full time, which is what I'm now doing. And so, where am I? Sorry, I lost myself totally on the screen there for a moment. So that brings me up to the sort of modern day phase of QRPLabs, where since June 2016, I've been working on QRPLabs full time, and that led to the next major product, the QCX-CW transceiver, which you can see pictured here. Now, the QCX, for several years, I had actually wanted to produce a transceiver kit, and in fact, I had all of the modules to produce a transceiver kit already on the market. So I had a Si5351A digital VFO, I had a receiver module, I had a 5-watt power amplifier module. All of those could actually have been put together to create a transceiver kit. But the problem is, and this is a very important lesson, if you combine a set of general purpose modules to produce a specific product, you get something that works, but you end up with a very expensive product. If you want a low-cost product and you want to tailor it and optimize it for the particular feature set that you want, then you really have to design something that's custom made for the job. And so that was how QCX came about. But the actual beginning of QCX was an email, which I've reproduced here. I found this in my archives, and from the YOTA 2017 Summercamp organizers, who informed me that they were having a Buildathon in August 2017 for the Youngsters on the Air Summercamp, which was hosted by the RSGB in the UK in 2017. And it says here, we're planning to have all attendees do some radio construction. We have about £1,000 to spend and 78 attendees from 29 countries. And they were asking for suggestions on what kind of kits I might be able to offer. And at the bottom there, it says, if you'd like to chat, Steve Hartley is the project manager. Now, we all know Steve, G0UPL, is now the G-QRP club chairman. At that time, he was the RSGB board chairman. And so when I saw this email, and I got about as far as the £1,000 for 78 attendees, and I started laughing, and I just deleted the email because I thought, what could you do for £1,000 for 78 attendees? A little bit of arithmetic showed me that in dollar terms, that was about $16 per person. And I thought, you know, you can't really do anything serious with $16 per person. And perhaps you can buy some very cheap Chinese transceiver kits, but you won't be happy with the performance and the documentation and everything if they work at all. And so I just deleted the email. But then somehow, as the hours went by, the topic wouldn't leave my head. And that evening, just a few hours later, I wrote an email to Steve, and I asked him do the youngsters like CW, and how about this CW transceiver kit? And I had already laid out a whole list of the possible specifications for the kit, which included synthesized VFO tuning across the whole band, so not just a crystal controlled oscillator which controlled just a few kilohertz of the band, a really professional whole band tuning with rotary encoder with a 16 by 2 character LCD screen to display the frequency and everything else. I wanted to include a CW decoder because I wasn't sure whether all of the youngsters would have had access to CW and would have used it. I wanted to include a keyer on the board itself, as well as a micro switch as a key. I wrote here a couple of watts output that later increased it to 5 watts in the end. And single band, I suggested 40 meters there. The final kits in the end were built for 17 meters because it was YOTA 2017 and it seemed like a good resonance with the year. So they were built for 17 meters. And with really high performance single sideband RIT, and so that was the basic specification for the QCX, which was proposed within a few hours of that original email, which I had originally deleted. And a few hours later, I had a nice Skype chat with Steve, G0UPL, and we talked about this, and he was interested in the idea. But I quite imagine that they had sent this email asking for kit proposals to a number of QRP kit makers, and I wasn't the only one. And so they had to wait for others to reply, and then there were various committee meetings which went on. And it wasn't then until May 2017, if I recall correctly, that I received the final go-ahead to produce these kits for the Buildathon. And the plan was to charge the $16 as they had planned for the £1,000 budget, and then to produce 200 kits and to sell the remaining kits at a profit so that I could break even on the whole project. That was the idea. And so in the end, I produced the first batch of 500 kits, not 200. And I remember after they went on sale, the remaining 410 kits, because the RSGB took 90 in the end and there were 410 left over, they sold out in 28 hours. So I had no problem at all on the breaking even part on the project. So it was a very impressive and quick sales. So I had to wait until May to get the final answer, and by then I was already in Dayton for the Hamvention, FDIM Hamvention, and I was then a month later going to Friedrichshafen for the European Ham Fair at Friedrichshafen, Ham Radio Ham Fair. And so time was really, really tight to finish this by the beginning of August and to produce these kits and to write all of the firmware and all of the documentation. It was a really tight schedule, but fortunately, I hadn't actually waited for the RSGP decision. I decided to press ahead anyway because I was so excited by the idea. And as I said, for a few years, I had been wanting to make a transceiver kit anyway. And so the idea had taken on enough momentum that I didn't even need to wait for their answer to be able to start working on it. So on the 9th of March 2017, which is something like 2 weeks or so after the original email, I had the first QSO with it. And this was my development version. You can see it's using a front panel from an Ultimate 3S kit to hold the LCD module, and the processor behind it was actually an Ultimate 3S board, which held the Atmega 328 processor I used. And then various parts of the circuit built by a combination of matrix board, an SMD chip holder, some ugly construction, and it was quite a mess there. I still have this, and I'm thinking one day to revive it and to actually, because it's a piece of history now, that development. So it was just 2 weeks to have that first QSO, and it worked very well. But of course, going from a first QSO with a lash-up board like that to a proper, professionally laid out PCB design and firmware that supported all the features I wanted was quite a major step and took a very long time, and all the documentation. I won't read through this. This is the whole full specification of QCX, the final specification. Just some important points from that. There's a choice of single band from 80, 60, 40, 30, 20 or 17 meter. And the RSGB, as I said, chose 17 meter for the Buildathon. subsequently, when it went on sale, the most popular band has been 40 meters, followed by 20 meters. An important point is the Class E power amplifier, and I was very pleased with the result from that I used 3 BS170 transistors, small TO92 transistors. They're very cheap, and because it's Class E with a high efficiency, some are over 80% efficient, they don't need any heatsink. And that was an important consideration because a heatsink would have increased the cost considerably, as well as the board area and the weight and everything like that. So everything about the QCX had to be designed to get as close as possible to that $16 budget for the YOTA Buildathon. So it was all designed with efficiency and low cost in mind. Nevertheless, it has produced a very high performance receiver in which there is at least 50 decibels of unwanted sideband cancellation. When it's properly adjusted, and it's not difficult to adjust, it has all its own built-in test and adjustment equipment. It does have a synthesized VFO, as I mentioned, quite a narrow 200 Hertz CW filter, so it really works very well. It has all the features that you like 2 VFOs, split operation, RIT. You can configure everything. It has full break-in operation or semi-break-in. It has a keyer, iambic keyer built in, and it also, I added a whisper beacon mode to it so that it could operate as a whisper beacon. That was kind of a bonus feature. Now, a little bit about receiver architectures generally, and going back, because I wanted to also stress the point about modern transceiver architectures for QRP, and this was going back into history a bit. Many of you will be familiar with NE602, which is also known as 612 or SA602, 612. They're all pretty much equivalent. And I believe that this was introduced around 1985. That was the earliest reference I could find to it in a Signetics data book I found online. It was later owned by Philips and NXP. And this is a tiny 8-pin chip that you see there pictured that was originally intended for cell phone applications and contains a mixer and an oscillator, and was soon discovered by radio amateurs. Now, I call the subsequent transceiver architecture which arose the Cold War sandwich, because it contains 2 SA602s and the crystals in the middle, crystal filling. And the earliest reference I could find to this architecture was by Rick K1BQT in ham radio in 1987. And this architecture has been by far the most popular architecture for homebrew QRP receivers ever since. So it's getting on for 4 decades of copying this basic same architecture, superhet receiver architecture, using 2 SA602s. And why? Because it works. It doesn't cost very much. It's quite easy to build because these chips contain the oscillator and the mixer and some gain. But on the other hand, it does not have great performance. It's susceptible to strong signal overload with quite poor dynamic range. And this is a consequence of the fact that it wasn't really designed as a front-end mixer. It was designed as a second product detector at 45 megahertz for cellular applications. So it's being pushed into amateur radio use, typically on HF, where it's not really designed for. So even today, there are transceivers available commercially on the market, such as the LNR Precision Mountain Topper radios, which also use this same architecture. Now, the direct conversion receiver, such as the one that my first transceiver, the Wolford 160 meter transceiver kit that I showed you earlier, is a direct conversion receiver with only a single oscillator mixer followed by an audio amplifier. And this has been a very popular first introduction to homebrewing a receiver, including by me. And but it, as I said, it does suffer from the disadvantage that the SA602 is not particularly good at handling strong signals. And direct conversion receivers can have other problems too. With all the gain being audio, they can suffer from power line hum and microphonics. And of course, the main disadvantage is that you hear both sidebands at the same time. So if you want to listen to upper sideband, then you're also going to hear signals on the lower sideband, which is going to interfere with you as well as increase your noise floor. but they do sound very clean, and because you don't have any birdies from unwanted mixing products. So next on the list is the phasing method direct conversion, which I showed you my first receiver in 2002. Now this uses two mixers and a VFO which is split into two different 90-degree phase shifted versions at the same frequency, and then you add an audio frequency to one of the output paths of the mixers and then sum them together. And magically what happens is that one of the sidebands is reinforced and the other sideband is cancelled out completely. Now in the real world, the phase shifts are not completely accurate at 90 degrees. Particularly audio phase shift is hard to do because you need that to cover a wide range of audio frequencies. So for SSB, for example, you might need it to cover from 300 hertz to 300 kilohertz, from 300 hertz to 3 kilohertz. And that's quite a wide range to be able to do with an analog phase shift circuit accurately. And so due to inaccuracies, that's where the limited unwanted sideband cancellation of 40, 50, or sometimes more decibels comes in. But in the SDR world, in the modern software-defined radio world, it's possible to do this audio phase shift very accurately in digital signal processing. And because of that, this system is now used very, very commonly in many commercial applications because it really makes a very easy receiver architecture to implement in modern devices. One of the important things that I learned from the Tech Topics column, as I mentioned from the Radcom periodical, was the quadrature sampling detector, which is also known as the Taylor detector, which has a multiplexer that switches the input signal into 4 different paths, which are then summed and differenced by 2 operational amplifiers to provide the 2 audio outputs, which are typically called the I output for in-phase output, and the quadrature output, which is called the Q output. And these are then passed through an audio shift network, phase shift network, as I mentioned. Typically, you don't have to just shift one audio path by 90 degrees. What's important is the relative shift between them. And so you often see shifts on both paths, but the relative shift is 90 degrees. And then you sum the output and get rid of one of the unwanted sidebands. Now, this system was patented by Dan Taylor. He wasn't actually the first to find it, but he was the one who mostly popularized it and documented it and produced radios using it. It's very convenient for modern components. There's the FST3253 bus switch, which has about the 5 ohms on resistance and very fast switching, which really operates in an ideal way for this. And it produces very high dynamic range, very high third order intercept, plus 26 dBm is a number often quoted, and with also very low loss. So because of this, at low HF, you typically don't need an RF preamplifier in front of the mixer because the loss of the mixer is so low, and so you can still achieve adequate sensitivity. This was a chart from Dan N7VE's presentation on the NC2030. The NC2030 was a transceiver that Dan designed in, I believe, 2004, and implemented the quadrature sampling detector to produce a very, very high performance transceiver with really high dynamic range and at low cost. And he was selling the kit at the time for $150. And you can see there on the chart that it outperformed many of the famous radios there on the list, which cost 10 times or more of the price. And the QCX was really inspired partly by the NC2030, which was a good implementation of the Taylor detector, and also partly by my earlier experiments with the Taylor detector that I mentioned before. So this is the implementation in the QCX, and it's a double balanced quadrature sampling detector. So you see the T1 transformer there on the left splits the signal into 2 180-degree phases, and they're then summed on the other side. That presents some benefits in common mode rejection, supply hum rejection, AM rejection, and so it's worth doing anyway because the FST3253 has 2 halves in it, so you can just use them as a double balance mixer. And that's my implementation in the QCX. Now the next important thing is the oscillator, and this was where the QCX made use of technological advances since Dan's NC2030 had been designed in 2004, because now we have available this SI5351A chip, which costs less than $1 per chip, even in quantity 1, and it provides a rock stable output. It provides actually 3 separate outputs, which are individually configurable. It's configured by a microcontroller, and it has a very wide range of 3.5 kilohertz to over 200 megahertz, very fine resolution. And this replaced the whole analog signal generator architecture in the NC2030. So the NC2030 had an LC-VFO, I think a permeability tuned oscillator, which was mixed up and then divided down to get the quadrature LO. And that was quite a complex amount of circuits that was in the NC2030. And now with modern technology in that tiny chip, which is just 3 by 3 millimeters, you can see it there on the QRPLabs synthesizer kit board on the bottom right, all of that is implemented very simply. It's also been used by Elecraft in their KX2 transceiver, which is a very highly regarded transceiver, and of course in the QRPLabs QCX. So that was a major innovation to be able to use that, and really cuts down on the circuit complexity to be able to implement a high performance transceiver. Now, for the quadrature sampling detector, the typical way that the quadrature signal was generated, and you can see there at the top right, I've got a diagram illustrating this. There are 2 signals which offset by 90 degrees of the RF cycle. And the typical way that this was done was to use an oscillator at 4 times reception frequency fed into a dual flip-flop arrangement, which is shown there on the bottom right, which produces the 2 paths. The disadvantage of this is that you need to be at 4 times reception frequency. Now, with the SI5351A, that's not hard to do because its top range goes up to 200 megahertz, but with an LC oscillator, it was obviously a lot harder to do. So I actually developed a method to create quadrature offset on 2 of the output channels of the SI5351A, and directly, without needing the 74AC74. And that was very beneficial because it eliminated that 74AC74, which cut down on the complexity of the board area and, of course, the cost, which was a key consideration for the QCX project for the YOTA with the limited budget. This chart shows the unwanted sideband cancellation, and you can see there, sort of near the left, at 700 megahertz, where you want the CW tone to arise. There's better than 60 dB of unwanted sideband cancellation. It was a little better. The red line is using the SI5351A, and the blue line is using a more conventional 74HC74 divider, the dual flip-flop method. And the results were a little bit better with the SI5351A, which also was very pleasing. The next thing to mention is that the modern transceiver contains a microcontroller to look after everything. Now, this is like a miniature computer in a chip. It has EEPROM for persistent storage of your settings and configuration, which is very useful. And things like a DDS or an SI5351A or its earlier variant, the SI570 and a predecessor, all of these really need a microcontroller to set up the frequencies that they use anyway. And once you have the microcontroller in your project, you can include all sorts of other things, like very easily handling transmit-receive switching and sequencing the delays. So you want to have an RF envelope with a 5 millisecond rise and fall time before you switch back to receive. And you can control all of that sequencing with a microcontroller. You can have the microcontroller generate the side tone with a configurable frequency and volume. You can add frequency memories, message memories, VFO-A, VFO-B, a keyer, CW decoder. All of these things could be added once you have a microcontroller in your project. As long as you can write the firmware for it, you can add all of these features. And essentially, you're adding them all for free. They don't have any associated hardware because you're doing it all in software. And so it eliminates a lot of pieces of hardware which would have added cost and complexity to the project. So you no longer need an oscillator to generate side tone. You no longer need circuits to sequence the transmit-receive switching or generate delays, because all of that can be in the microcontroller. So it's a very major step forward in a modern transceiver and helps to get the performance at the low cost. I mentioned the CW decoder. This was an example of it in operation. There's some limited digital signal processing. The processor I used is only an 8-bit processor at 20 megahertz, so There isn't a huge amount that you can do there, but the CW decoder does track the amplitude and the sending speed, and it works quite well. At least it's good for practicing on your sending and seeing how accurate your own sending is. And many people have commented, in fact I received an email just this morning, people have commented that learning to use CW, it's a really nice tool because it lets them practice without transmitting and decode their own transmissions and see how accurately they're sending. The QCX also has all its own built-in alignment tools and test equipment, and this really made it unique in a radio of this price class. But again, it's something that you can easily achieve once you've got the microcontroller on board. If you use it carefully, you can have all of the configuration and setup tools built into the radio itself. And I originally did this because I could imagine the poor RSGB at the YOTA Buildathon running around like headless chickens, a few supervisors and a few pieces of test equipment, and not having signal generator for everybody or an oscilloscope or any things that you might think that you need to set up a radio receiver. And so I thought if I could build all of that into the design itself, that would greatly simplify the requirement on test equipment at the venue itself. So that was the original motivation. It's been very well received ever since. As I said, it also has a whisper beacon in there, which this was just a bonus feature added at the last moment. So you can put in your grid locator, or indeed you can connect the GPS to the transceiver, and it will operate as either a whisper beacon or a CW beacon, converting the latitude and longitude from the GPS data it receives from the GPS receiver if you connect it. Whisper is a whole nother topic, so if you're not sure what that is, please look it up because we're probably out of scope for now. Now here's a bit of on-air testing, and this was my son. He was 21 months old at that time, and this was during the development of QCX, and he just came upstairs to the lab and he told me to get off my chair, and he pulled himself up, climbed on the chair and started keying the QCX and listening to the side tone. So I draped the earphones over his shoulder, and finding that the earphones were far too big, these were Apple iPhone earphones, they were far too big to fit in his tiny ears, so I just draped them over his shoulder and grabbed the camera and took a photograph. And that photograph actually was on the front cover of a German magazine art issue in January 2018, CQDL January 2018, so it's a nice photo. And that concludes this second part on the QCX development. Now I want to move on to talk about the QCX Plus briefly. The QCX Plus was introduced in May this year. The QCX had been built successfully by constructors from 12 to 91. There is Lauren on the left, who I met at the National Hamfest in UK in 2017, and Phil on the right from Canada. I'm sorry, Phil, I forget your call sign, who's 91 years old. And so it was constructed by a wide range of people, but nevertheless, quite a few people said that the component density was high and it was hard to build. Furthermore, it was clear that the QCX was not easy to enclose because the buttons and the knobs were all at different heights relative to the PCB. So various people had been very inventive, and there's a gallery of QCX kits at the QRPLabs webpage in mounting their QCXs in various ways, often involving moving the controls off the board, but sometimes involving shaft extenders and button extenders. There are a variety of 3D printed enclosures, so it was very fun to see how that all came together. But nevertheless, it's very difficult, and most of us are not so good mechanically as we are at soldering, and so the issue of the enclosure was a bit of a thorn in my side. There was an enclosure produced by a German company, BaMaTech, and it's still sold today. Relatively expensive, 32 euros, but a very nice enclosure made of bent aluminium and machined parts for the shaft extensions, for the volume control on the left and the rotary encoder in the middle, and some extenders also for the buttons. So that fits a standard QCX without modification and without moving any of the controls or the display off board. So the other minor issues were when operating the whisper mode, often the BS170s would overheat. There wasn't any on-off switch. As the firmware had developed, new features were added. CAT control was added, and PTT, there's a PTT output was added because there was a 50-watt power amplifier kit. Sorry, I'm not supposed to mention this at a QRP convention, but this 50-watt power amplifier kit required a PTT control from the QCX, and there were no connector provisions for that. But the main one was the component density. And so what I did was I designed a larger version of the QCX, which has the same circuit diagram and the same firmware, the same operational characteristics and performance, but a much lower component density with double the PCB area. And it also adds controls for the CAT and PTT and an on-off switch. It has a front panel arrangement at 90 degrees to a main rear panel, and all the controls in the LCD are there on the front panel. And if you see there on the bottom right photograph, you can see that they're all at the same height relative to the PCB, so it's relatively easy to fit it behind the front panel. It was also designed for easy experiment and modification, being larger, and it has pads all over the board at important places to make connections if you need to. And I heatsink the PA transistors by bolting them to the PCB, so the PCB acts as a heatsink, and that just makes it less likely to overheat it. This is a photograph of the main board, and you can see here there are these connection points in various places, and overall a much less dense layout. It also had an optional aluminium enclosure. This is a very sturdy enclosure. The aluminium extrusion is extremely strong, and it's cut, drilled, and laser etched to match the QCX, as you can see there. It's still a very compact unit. It's about 10.5 centimeters wide and 5.5 high and 14.6 centimeters deep. So it's quite a compact unit still. And there are other options too. So I added this TCXO option, which is particularly useful if you want to use it for WSPR. Excuse me, my throat getting dry. And this is a very nice QCXO, which is low cost, but at the same time has quite high precision. I measured about 0.25 parts per million, and it fits on top of the main board in place of the 27 megahertz crystal. So that was one option. And the second option was a dev kit, which I created, which is a 0.1 inch matrix of through-hole plated holes on a PCB that you can just build whatever you like onto it. And it has header connections which match the positions of all of the connection points on the main board, and it includes pin headers such that you bolt this dev board at a 12 millimeter height above the main board using supplied hardware, and with supplied connectors you can connect to the points that you want. So if you wanted, for example, to convert it to a SSB receiver and replace the CW filter with a SSB filter, you'd be able to tap off the necessary points and build your circuit on this top board. You can see there's also lots of space if you wanted to include things like batteries on that board. That would be an option too. So as a price comparison, the original QCX kit was $49, and the new 5-watt transceiver kit is $55, so it's slightly more expensive, only slightly more expensive, despite the fact that it's more than twice the PCB area and has additional connectors and other controls. The enclosure is $25, which is actually cheaper than the BaMaTech enclosure, and of course it's all shipped from one location rather than having to buy the enclosure separately. So overall, this upgrade to the QCX Plus in the product line actually lowers the price for most people who buy the transceiver kit and the enclosure kit. It actually lowers the price compared to the original kit, at the same time as providing quite a lot of new features, as well as those quite low cost options of the dev kit and the TCXO option. Just a few interesting facts. The first batch, as I said, was sold in just under 28 hours. And as at the time of writing, there have been almost 11,000 QCX kits and QCX Plus kits sold since August 2017. 11,000 kits for a monoband CW transceiver kit should really inspire everybody to know that QRP and home construction is alive and well, because 11,000 kits in 3 years is just a phenomenal number. Around 40% go to US customers and 15% to UK and Germany. That's the geographical distribution. Most people chose the 40-meter band, about 45% of people, with about 40% choosing the 20-meter band. And over 90% choose the enclosure option we found since May this year with the QCX Plus. So that really reinforces what I said about many of us not liking metalwork or mechanical engineering work and being better at soldering, about 50% of people add the T60 and another 25% add the dev kit option. So moving on to part 4, and remembering that, you know, it's always the case that you can't please 100% of people 100% of the time, but there are occasions when enough people complain about something that you should listen. As a business owner, you should listen. And in this case, there were quite a number of people who started saying, well, the QCX Plus is very nice, but it's too big. And we want to go on portable operations, we want to climb up onto hills and mountains for SOTA operations, and we preferred the older QCX format, which is much smaller and lighter and is more convenient for portable operations because the controls and the display are on the top panel. So the question arose what to do about this, and should I bring back the QCX or should I make an SMD version of the QCX? And in the end, I decided to make an SMD version, which is basically supports everything that the QCX Plus has, but in a much smaller enclosure. It also supports the QCX Plus T60 option. It's a very small enclosure, just 92 by 63 by 25 millimeters. And it also has a yellow-green LCD with a backlight that can be switched off. This can be very easily read outdoors, and lower current operational amplifiers. And this is now, this is an image here of the 2 panels which the PCB is on. There's a main PCB with most of the components. That's the left one here. And then a right PCB which kind of fits on top of that in a sandwich, which controls has the LCD and the various controls. The right PCB snaps off into a couple of smaller ones, which will fit together in the right places to fit into the enclosure. Now the enclosure, if any of you are aware of the 50-watt PA kit, sorry to mention this again on the QRP convention, I know I shall be thrown out and disconnected for this blasphemy, but if anybody's aware of that, the enclosure is the same extrusion but cut to 92 millimeters length. And this is a drawing of how it will look with the laser etched engraving and the controls cut and drilled as well. So the current status of that is that I'm waiting for the prototype boards to arrive any day now, and the enclosure is going to be, a sample will be finished manufacturing next week and then will be on the way to me, and SMD components are also on their way. So I'm waiting for that to arrive and then we'll construct a prototype. So I'm hoping that this will be available in around November 2020 at a similar price to the QCX Plus. And really, this is not a big project insofar as the circuit diagram and the firmware are all the same as the QCX. So it's really a sort of a different mechanical implementation, but not a huge amount of R&D required. And therefore, it's not expected to be a big project which drags on and gets delayed. Now, moving on, the final part is about the QSX, all-mode, all-band HF transceiver. Now, this is something that was introduced for the YOTA 2018 Summercamp, which was a Buildathon in South Africa, and which I actually attended in person. This aims for a very high-performance HF transceiver, which really would perform as well as your top price branded Kenwood, ICOM, Yaesu, whatever transceiver across HF from 160 meters to 10 meters with 10 watts on each band. This is a real 10 watts. During the development of the 10 watt linear, it was tested with 10 watts continuous key down for 1 hour without overheating. So this is not like many commercial transceivers where they say that they are 10 watts, and that's fine, they are 10 watts PEP. But if you try to operate them key down for digital modes for a long period of time, you'd be in trouble and they'd overheat. This is a real 10 watts. And at the same time, at a very low cost, filled with features, everything you'd really expect in something that was 10 times the price. Unfortunately, this is still in development, and this is a question which probably most people ask more than any other question, is when will this be finished? And I'll come on to that in a moment. It was a tremendously ambitious project, stupid of me really to think that it would be done quickly and that I could finish such a thing in a short period of time. They did build a version of it in the YOTA 2018 Summercamp, and this is a photograph of the British contingent there in the front row building the kit. I took that photograph in South Africa. So the receiver, this is the challenges about adapting the QCX for sideband. really, when you try to adapt analog from a CW transceiver to do SSB, you run into a lot of different problems. So for SSB, you definitely want AGC, that's one thing. The audio phase shift is much easier to do for a narrow band for CW than it is to do across the whole audio bandwidth, and that's the problem. You want to have different CW filter and SSB filters, and you perhaps, if you're going to do it multi-band, you need a much more complex band passing arrangement than the simple one that was in QCX. On the transmit side, we need a proper single sideband exciter chain followed by a linear amplifier chain. This is all much more complex than the simple class E amplifier that was in the CW transmitter. You may want other things like speech processing and CW key shaping, and all of these things lead to a very, very much more complex circuit if you try and do things in an analog way. The solution is software-defined radio, which has the flexibility to implement all of this just in software, and which you can easily modify and upgrade and add new features without any hardware changes at all, just by installing new firmware. The disadvantages, of course, is that you need a computer and you need quite high performance conversion between the digital and analog realms. And of course, digital signal processing sounds pretty scary, and it's all in software, so it involves a lot of software development. Many of these problems can be solved, and you know, for using a computer, you can actually use a powerful processor. So the STM32 series are very popular, and a 32-bit ARM processor, costing only a few dollars, but with plenty of processing power to implement an SDR on the chip in the device, so that you don't need to connect any external computer to do the signal processing. 24-bit ADC and DAC chips are available with very high performance, and again, very low cost. And it turns out that the overall cost of replacing all of the analog circuits that would be required by this microcontroller and a high performance digital to analog conversion is actually much less cost than the equivalent analog circuits would be. So you get higher performance and more features for less cost. We like that. Now, as far as being scary is concerned, the internet comes to the rescue there, because there are a lot of tutorials, a lot of examples, things that you can find that demystify the magic. This is a block diagram of the QSX, and you can see that basically the processor sits there in the middle. The audio from the microphone is digitized and put into the processor, and is processed in the processor and produced in the I and Q channels come out from a digital to analog converter. And an exciter is basically a quadrature sampling exciter, which is like a Taylor detector in reverse. And on the receiver, you have the standard Taylor detector followed by an ADC. The I and Q channels are demodulated by the processor, which can do so very accurately and can also handle AM, FM, upper sideband, lower sideband, CW, all of those modes just by changing the digital signal processing. At the same time, the processor can handle all the user interface, buttons, rotary encoders, everything else that you need. Excuse me, I'm a bit blocked up here. So all of that basically is handled in the processor, which is the heart of everything. And the key point here is that the cost of that processor and the analog to digital conversion is less than all of the analog circuit blocks that you would otherwise have to do in an analog radio. And so from a commercial perspective, it no longer makes sense to do everything in analog, because doing it digitally improves the performance and the features that you can implement, and also lowers the cost. So it's no longer really possible to justify an all analog design in 2020. And this is why most of the commercial manufacturers you will see have moved towards embedded SDR. Mechanical design is also important. This is a brief slide about the mechanical design of QSX. All of the controls are board mounted and fit into an enclosure and sandwiched together, so that all of the controls come out the front panel and the connectors come out the rear panel. There's a heatsink on the back. There are 3 boards. This is a picture of the front board. Controls has the 2 rotary controls and the LCD, and 4 buttons there along the front. You can see the tiny processor there in the middle, which is responsible for all the hard work. The rear board contains the RF sections, and bolted to the back of that there's a PA kit, 10-watt linear. This has already been available as a kit for some time, and has been demonstrated very high performance. It's been abused in all kinds of different ways. As I said, we did a continuous key down for 10 watts for 1 hour without it burning up. We did 20 watts for 15 minutes continuous key down. And yes, it did start getting very hot, but it didn't overheat or kill it. It's been operated into open loads, short circuits, various mismatches, and it's a very, very robust PA. At the same time, it produces about 26 dB of gain across from 1.8 megahertz to 30 megahertz with about plus or minus 1 dB flatness. So that small error in power output can easily be compensated for in the digital signal processing to get an equalized output across all the HF bands. So that PA kit is really a quite hard part of the transceiver and is already available as a kit. This is a picture of the PA kit on the heatsink. Since then, the heatsink has actually been changed to a black anodized heatsink. It doesn't make very much difference from a performance perspective, but it looks nicer. This is a prototype enclosure, rather battered, and of course hacked by me rather than produced professionally, but that's an idea of how it will be. Of course, it will be much tidier and with laser etch printing and so on, like the QCX enclosure, QCX Plus enclosure. Here you can see the rear panel connections, and note the two USB connectors there on the left. So it easily connects to a PC as a host and produces IQ output. You can plug a keyboard into it. There's a huge number of features. We don't have time to list all of those here. Now, one of the other features that I implemented was a high-performance solid-state transmit-receive switch that provides over 75 dB of isolation in the off state and less than 0.1 dB of insertion loss in the transmit state, and uses only cheap 1N4007 diodes, and it produces very fast and clean full break-in operation for CW. Now, a lot of commercial transceivers, even by the big manufacturers, don't actually do very well in full break-in CW, and I wanted this to be able to support CW with clean full breaking at whatever speed you care to operate at without any issues. So it was a key criteria. It was very difficult to do. Again, it has all its own built-in test equipment, and you can see also on the screen here I've demonstrated what I call the spectrum analyzer, which is where it can inject its own signal through the bandpass filter, and you can see a real-time passband plotted on the screen of the bandpass filter, so that you can adjust the trimmer capacitors to get it centered on the emitter band. So that's very cool. There's a YouTube video about that too. So in summary, QSX is going to be high performance, all band, all mode, 10 watts HF transceiver with a very low price, targeting $150 for everything, including the 10 bands, band switch module, the aluminium enclosure, and the 10 watts power amplifier. Now to the big question of when. I had hoped that this would be available by the end of 2018. And as then people started joking about, will it be in time for Christmas and which Christmas? And overall, the project has been very much bigger project than I had anticipated, a very much more difficult project than I had anticipated. You know, stupid me, I underestimated the workload that I would have on other projects, and of course overestimated my capabilities and underestimated the amount of work required. Another factor being that since this became public after the YOTA event in August 2018, a lot of suggestions flowed in for features to add, and all of those suggestions were very much appreciated, as well as you know, very useful suggestions that improve what the product will become, but they do of course all increase the development time, and you get this kind of feature creep going on. So additionally, of course, the QCX has continued to be a real blockbuster product. As I said, now almost 11,000 of them have been sold in 3 months, as well as the rest of the QRPLabs kit range. And so a large amount of my time every day, although I'm now working on QRPLabs stuff full time, a large amount of my time is on admin, support inquiries, organizing the manufacturing of new batches of kits, and all of these type of things rather than research and development time. And so it's not that I have 100% of every day to work on the DSP for the QSX. There's a lot of other demands. So I've stopped promising dates, and I've just said, it will be ready when it's ready. It will be worth waiting for. It'll be a very, very special radio indeed. I'm very confident of that, and at a very low price. Nothing like this exists at this price. Almost nothing exists at this price anyway, let alone being anything like this. And so it will be worth waiting for. I feel very lucky that I have not taken any pre-orders. I have not taken any crowdfunding. I have not taken investors, bank loans, any of that. I continue to support myself from the existing business rather than needing to take any advance payments or loans or investors on the QSX project. And that puts me in the nice position that at least I don't have to answer to real pressure from financial backers. I feel very, very much for Elecraft to announce the K4 at Dayton in May 2019, and of course took pre-orders, and those things are very expensive, of course, and people have given thousands of dollars, and they're still trying to get those out the door. So, once you take pre-orders, it's a very difficult thing and a lot of pressure. So at least I'm pleased that I didn't take pre-orders. I will work on it as soon as I can, and all of the other projects which I've been doing in the interim to keep things moving, keep the new kits flowing, have also contributed something to the QSX project in many ways. So a lot of the modules that were developed for the other kits have also been of use in the QSX project. So when, I still can't give a promise, but I believe it will be worth waiting for, and we will make progress towards it, and I will make announcements on the QRPLabs discussion group and newsletters when I can. So finally, in summary, this is just a summary of what we talked about. QCX is a modern analog design, all analog design. I think it's probably the last all analog design that I will do, because as I said, now SDR technology really makes improved performance and lower cost available. QCX Plus is an improved version of QCX with lower component density and some added features. QCX-mini will be a tiny version, which will be available in the next month or two, as soon as I've built that prototype. And QSX will be really the holy grail of my transceiver developments, which will be all band, all mode with embedded SDR, very high performance at very low cost. And as I said, really the benefits of SDR are very hard to argue with. You improve the performance and you lower the cost. I know that from a homebrew perspective, people like to be able to implement everything, analog components that they can see and understand, and modules. And I understand that and completely understand it and agree. From a commercial perspective, if you want to produce a kit, it has to be commercially viable. And in that case, SDR, I think, is very hard to argue with and will be the future. So finally, some more information. I have two websites, hanssummers.com, which I've had since 1999, and that contains all of my homebrew projects, including the Crystal Radio. And then I have the QRPLabs webpage and the shop, which is at QRPLabs.com, and has all of the kits which are produced by QRPLabs, my company, at the moment. And I've got two pictures on here, 1976 to 2020. And obviously I've come a long way in that time in the design of my QRP radios. And still loving it as much in 2020 as I was in 1976. And I hope for many years, indeed decades to come. Thank you very much for listening. And I'll go back to you, Nick, and answer any questions that there may be. Thank you.
Okay, brilliant. Thank you very much, Hans. And I was absolutely loath to interrupt you and try and get you to give a bit more time to answer questions. So I apologise to those that have put questions. We'll work our way through them very quickly. We've got 12 minutes to whiz through these. So just to save Hans a bit of time. The first question, Hans, was from Alan, W2AEW. Some have reported that the 612 doesn't perform as well as the 602 higher IMD. Personally, I haven't seen this. What do you say?
I don't think it does. I believe from the history, and there's a lot of myths that have been written about the history of the 602 and the 612. Way back, the 612 was an improved version and the 602 was a lower cost version. And so way back, I believe that there was a difference, but that goes back many decades. now, I believe that the current production, they're all the same, and there's no difference between them. They just have different labels printed on the front. They're all the same high-performance version of the chip. That's my understanding.
Okay, thank you very much. Next question is from Matt M0TEU. Hi Hans, are you planning to produce any SMD kit in the near future?
Yeah, I mean, that was answered by the QCX-mini, which will be an SMD. The QSX is also heavily SMD. One thing is I will be assembling the SMD parts in the factory, in the PCB factory. I will not be supplying strips of SMD components and expecting people to solder those. The reason for that is that probably about 90% of people don't want to solder SMD stuff. They only want to solder through-hole stuff. Furthermore, from a kit maker's perspective, SMD is a nightmare because it's much more expensive and tiny. All those tiny pieces are expensive to count out and kit and support, because people will be launching them across the room and have less than they need and everything. So I've decided there's no way I want to go into producing kits which require people to solder SMD, but because of the size and cost constraints of things like the QSX and the QCX-mini, I certainly will be using more SMD, but it will be factory assembled. But there will be still a lot of through-hole components which are required to be assembled by the constructor. So for example, on QCX-mini, all of the NV0 capacitors, the inductors, connectors, controls, the DIP version of the process, all of that is still through holes, so there's still a lot of construction to do.
Okay, thank you. I've got a question from Paul VK3HN. Would you consider a 2 or 3 band QCX-mini? I mean, he's making the point that for SOTA activation, 1 band can risk it.
Yes, absolutely I would, and that is something that I have already had in my mind and my plans for the future. It's something that, you know, with QCX-mini, I really wanted to answer the need quickly, and to do so by having a project that wasn't an enormous project. So I'm keeping it simple by using the same circuit, the same firmware, everything as QCX. So there's very little R&D involved. It's just rearranging the physical layout. But in the future, I certainly want to produce 2, 3, 4 band ultra portable miniature CW transceiver. I certainly want to do that, and it is my plan to do so. I don't want to put any dates on it, and I really want to finish the QSX first, but it is definitely something which I'm intending to do, yes.
Okay, brilliant, thank you. A question from Dom M1KTA. Have you looked at a Paperwhite display?
I have, and I actually reviewed all the different displays that I wanted to, that I could possibly use for the QCX-mini, and the e-ink, e-paper type displays are very good. They suffer from the problem that although they're very, very highly readable in sunlight, they have quite a slow update speed. And even if you update only parts of the display, they still are quite slow to update. They're also quite expensive, so they would increase the cost. I also looked at color TFT displays. I looked at OLED displays. The TFT displays are not that good outdoors, outdoor readable. OLED displays are better, but they still suffer a little bit in outdoor bright sunlight conditions. They also have higher cost, much higher cost, and they can generate RF noise as well if you're not careful. But fundamentally, as I keep saying, I wanted to keep the project minimal. I didn't want to go into a large R&D exercise and change the firmware and everything. Now, with the QCX-mini as planned, that yellow-green LCD display, if you switch off the backlight, it's sunlight readable still, even in bright sunlight. And so it's an ideal choice because it's very low cost. At the same time, it's very, very readable. You can switch off the backlight and it consumes very little current. So for these reasons, that's a very, very good choice for a mini. Although it's the oldest of the display technologies, it's a very good choice for a mini QCX. And e-paper would be nice, and I'd love to play with it, but I think the update speed would be probably a disadvantage for, you know, you don't want to be when you're tuning and you see the display of the frequency changing slowly a few times per second. That would be quite annoying.
Okay, thank you. Next question. How much latency will the DSP have? Will it adversely affect QSK and packet modes?
That's a very good question, and something which I'm aware that many of the DSP in commercial transceivers on the market implements quite a large amount of latency that makes full breaking impossible. And particularly SDR radios, which are using software packages on a PC, have difficulty with this because there's quite a lot of latency when you go through the device managers in Windows and everything to get to the software program itself. The latency, I'm aiming that the latency of the QSX will be so low that it will be possible to use full break-in CW at very high speed without any problems, because all of the processing is done on board, so you don't have to have any interface over USB to a PC and all the delays through that you get. I'm aware, I saw a table somewhere comparing latencies of different commercial transceivers, and some of them are quite horrific and would make full break-in totally impossible. I believe that basically here I'm sampling at 48,000 samples per second, and I'm processing in blocks of 48 samples. That means one block is processed 1,500 times every second. That's not the same as latency, because you have also latency through the digital signal processing, which is longer than that. But I'm trying to tailor everything that the latency will be minimal and full break-in operation. In my opinion, I will not release QSX until it works completely with full break-in operation. In fact, it already does. I had a QSO with Japan on 40 meters with my QSX at 5 watts output power with full break-in. And so it already does. So the latency will be low. That's very important to me. Yeah.
Okay, brilliant. Thank you. We are going to run out of time to get through all these questions. So I think the best we can probably do, Hans, is send you some of these through afterwards. And if you wouldn't mind responding, we can put them up on the G-QRP Club website. So I've got Martin, 2M0MVI. What about working in team and co-developing it with some other hams and experts in the field?
Yeah, that's a very interesting question, difficult question. I don't work entirely alone. I have had help with several things. Alison KB1 GMX has been very helpful. She's a very experienced engineer in the US about power amplifiers and was very helpful in consulting on the 10-watt power amplifier. Alan M0PUB was very helpful on the USB aspects of QSX. So I have had various assistants. I think it's necessary to weigh up how much time you would gain and how much time you would spend. When you farm out parts of the project to other people, or when you operate collaborative projects, that also has an overhead that takes extra time. There is certainly no shortage of volunteers, and if there is anything which I feel can benefit from being shared out to other people, I certainly will do so, and have been doing so in those 2 examples I mentioned at least, and perhaps others. But I think it's quite difficult to do efficiently, to collaborate, particularly internationally, with the time zone differences and cultural differences, and not all having access to the same hardware and everything like that. So it has to be done very carefully.
Okay. I'm going to group a couple of questions together. Sebastian DJ5SE asked, with the QSX shifting so much functionality into software, is there a chance it will be open source for us to modify and play with? And a couple of other people have picked up similar type questions. Jumiki JR1KRA, are they really educational for builders? Can they touch inside of the STM processor code? And a similar question from Simon VK3ELH. While understanding you'll need to retain your IP associated with software, if we're moving to an SDR world, do you have any plans for a project that will enable and help hobbyists understand and learn more about the software side of SDR?
Yeah, that's a very difficult question, and I can answer all of those together. Currently, none of the QRPLabs firmware is open source, and the obvious difficulty that comes from open source is the possibility of cloning. Typically, we talk of Far East cloning, Chinese cloning, but I believe that this is not the only source of the problem. There are cloners in a lot of other countries too, some of them very close to home. And I think that there are other problems with open source as well. It often ends up, again, the collaboration problem between people in different parts of the world, all pulling in different directions, different cultures, misunderstandings over email and forum posts, fights, egos. I've seen a lot of collaborative open source projects collapse under these kind of problems. So there are problems to open source, but fundamentally, I have to feed the family on this stuff. And the longer I can continue to feed the family on it, the longer I'll be able to produce nice kits that a lot of people are enjoying. And so because of that, I need to try and keep it viable and stop it from being cloned. So I'm not planning to open source it. However, I am including a very rich, a very rich programmability within the radio itself. So you can actually connect to the radio from a terminal emulator within a PC and program the functions of the radio. Everything about the UI will be scripted inside the radio in a basic programming language, which provides access to all of the functionality. So anybody who's familiar with Elecraft will know that they've got this macro functionality where you can set up macros that do anything within the radio that you want. And the similar concept will apply in the QSX, except with a very, very much richer feature set, where you'll be able to program entirely how you want it to behave, how you want the buttons to behave, what you want to display, what shortcuts you want to make. So all of these things will be able to be configured. So although it won't be open source, I'm hoping to make sure that it will be something that will be fun to use and people can configure. And if people want to get into that, they can make it do all sorts of things that they want to. And to try to provide sort of hooks into it so that if people wanted to add something like a Raspberry Pi to do something else, which there is space for inside the enclosure, then they would be able to tap into the I2C bus, for example, and the serial bus, and arrange communication between the QSX processor and the Raspberry Pi to do whatever they need to do. So I'm not planning to make it open, but I am planning to make it as configurable as possible and programmable as possible. There's a YouTube video I have on the U4B balloon tracker, which also uses a similar system, a similar basic interpreter and command line compiler, editor and everything all on the chip itself. So there's a YouTube video which explains some of that. So yeah, it won't be open source, but I'll try and do everything I can to make sure it's configurable and programmable and interesting to use with all of this inside it.
Okay, brilliant. Hans, I'm going to say first of all, to those asking questions, we haven't got time, sadly, to go through every question that keep popping up on the screen, but that was a brilliant opening webinar, I think, for this convention. I'd like to thank you very much on behalf of the G-QRP Club for your presentation. And I know from watching the chat while you were talking, there are loads of people busily ordering from you now and inspired to go off and build some kits. So I'd like to say well done and keep on doing what you're doing. It's been absolutely brilliant, Hans. Can I just, before I close, just indicate that at 11:05, we're going to open up the two separate meeting streams. Stream A is QRP Knowledge Share 1 on the subject of using antenna analyzers with Heather M0HMO. And Stream B, our QRP Knowledge Share 2, is running a QRPD expedition with Dom at M1KTA. So in a second, I'll end this. Hans, thank you again. Absolutely fantastic.
Thanks very much, Nick. Yeah, I obviously put slightly too many slides in for the amount of time. Very hard to judge, but sorry, we didn't have time for all of the questions. But yes, I mean, if you could collect all the questions and send them to me in some form, then I can certainly answer them textually. And if anybody has any other questions, you're welcome to email me, hans.summers@gmail.com. We've also got the QRPLabs discussion group on groups.io. So, I'm quite easy to find. Any questions you can ask me directly. But if you collect together all the remaining questions, I'll be happy to answer them. Sorry again about my microphone, and sorry about my sinus problems, which are blocking up my nose and not making it any easier to talk. So I hope I was audible to most of you. And again, thanks very much for the honor of being the first presentation. That's amazing. So it's been a great honor, and I hope you enjoyed it. And good luck with the rest of the weekend. I'm not going to be able to attend the whole thing, but I'll try and pop in when I can, and hopefully the panel in the closing stages tomorrow evening. So I'll try and attend when I can. It looks some very interesting talks. So good luck. Thanks again.